So now you've arrived at chapter 7. This is my absolute favorite chapter. I absolutely live and breathe hurricanes. As you may have seen from some of my posts, I do quite a bit of hurricane research, from flying through the center of the hurricane, which I have done a couple of times, to my evacuation research, where I try and understand people's reason for evacuating or not evacuating, and other studies look at why we have particularly active hurricane seasons and less active hurricane seasons. For a hurricane to form, the conditions need to be just right. It's sort of like Goldilocks and the Three Bears. You can't have ocean temperatures too cold or wind shear too high. It has to be just right. So a few important ingredients that are necessary for hurricanes to form include those warm ocean temperatures. It's not enough just for the ocean surface to be warm, but you have to have warm seas to a depth of around 60 meters. The reason for that is that as the winds come in, the strong winds, and kind of churns up the ocean, if the cooler water from below is churned up to the top, that will kind of cut off a hurricane from developing. But if you have warm water to depth, then you have warm water brought up to the surface and the hurricane can continue intensifying. We want high relative humidity because then you've got the opportunity for condensation to occur. When condensation occurs, latent heat is released. This is an additional fuel for the hurricane to continue to intensify. We also want our low vertical wind shear. So vertical wind shear is looking at the difference between low level and upper level winds. And you don't want that difference in direction or speed to be too much, otherwise it will just rip the hurricane apart. Hurricane names are now based on both male and female names. A big reason for that is that women didn't want to be associated with something so destructive as a hurricane, because in the past they were just given female names. So now we have male and female names. Hurricanes are categorized currently based on the Saffir-Simpson Hurricane Wind Scale. The problem with this is, as the name implies, it's just a wind scale. However, we know that the impact from a hurricane is much more than wind, particularly water. So I have worked with a team, and we've actually published a paper where we suggest that the Saffir-Simpson Hurricane Wind Scale should not be used for the public who rely heavily on this to make their evacuation decision. Instead, we want other factors to be considered in a scale, such as you could have the flooding, the rainfall, storm surge that creates that flooding. So we look into some of those other factors. If you take a hurricane such as Florence, for instance, which impacted the Carolinas, it was originally a major hurricane, and people started to evacuate as it was approaching shore. As it got closer, it dropped, and it wasn't a major hurricane anymore. It dropped to a Category 2 and finally a Cat 1 on landfall. As it was no longer a major hurricane, those that had evacuated started coming back. Other people just didn't evacuate because they saw that it wasn't a major hurricane anymore. However, they had massive impact, massive flooding. So that category really didn't tell them anything about the flooding, the damage, and the destruction and deaths that Florence would cause. Many of them made all their decisions based just on a wind storm, a wind categorization system. So the chapter looks at the frequency and intensity of hurricanes, and what that means moving forward with climate change, and also talks about some very famous and infamous hurricanes such as Hurricane Katrina. Hurricane Wilma occurred in that same year in 2005. You'll learn about rapid intensification. That's when storms drop their pressure very quickly in a day, and as they drop their pressure, they become very intense. These storms are very hard to predict. So I hope you enjoy learning about hurricanes as much as I enjoy hurricanes. And please check out the extra resources in this chapter. Thank you very much.